All right, this is a Galaxy Saturn that I've been working on a lot because it's been devastated by, I don't know, maybe one, maybe two, maybe three different people that tried to fix it that he sent it to. It had a lot of issues, to say the least. It had a terrible 21.250 megahertz harmonic uh, on the output that was just devastating sideband, and sideband's the only place it showed up, so it was really a process of me going through step by step the different sections that can cause that. I eventually found that problem. I wish I would have made a video on it, but it was two things. They replaced two diodes backwards in the circuit, and these just happen to be diodes that can cause issues with respect to sideband. Uh, I replaced those with the original ones that belong in it and put them in the right way. This was, I think it was, let me look again here. It was 17 and 16 and 17 maybe, or, okay, what were you? Yeah. In the receive section, it was D15 and 16. These are two diodes that were put there to kind of handle some of the excessive power that you might see if somebody's sitting in your driveway running 150, 2, 3, 400 watts or whatever. Supposed to protect the front end, what we call the front end, which is the first receive preamp station in the radio. In this case, it's TR17. The 3614 beast chassis, all the same. It doesn't matter what version it is, they're about 99% the same. Very little changes over the last 40 years. So anyway, once I got that fixed, um, I also had to replace TR17 because when they put those in reverse, it systematically blew the first preamp stage TR17 in the receiver. So got that fixed, and then I was on to the final section, and here they had the bias set up to 216 or 17 milliamps. Uh, One of the controls was damaged, VR10 was damaged, I replaced it. I got this set down. As a general rule, you'll want TR44, which is a pre-driver stage, you'll want that at about 50 milliamps, and then you'll want a combination of TR56 and 43, which is the final section. You'll want those coming out like VR10 will be the last. What would be in the line of circuitry would be considered to be in series with TR56. So first you take TR43, you set it to 0 all the way to one direction. Then you adjust TR56 to 50 milliamps, and then you adjust VR10 to show 100 milliamps. Got that all straightened out. Got the SSB power on VR12 fixed. Uh, Put some stuff back in that they took out with respect to open up the audio wide open, replace those transistors. I think in this one it's TR32 that they snipped. I put that back in, replaced all the electrolytics on the board. He wanted that anyway, the owner of the radio. It was just a process of finding all the problems, radically misaligned everything. I have to replace lights in this and all that, but I didn't want to do any of that till I had all these other issues fixed. I'm sorry I didn't make a video on that. It would have been very interesting to watch the process. Now I'm trying to fix the, if you can see it on here, this meter here is supposed to show power when you transmit, and it shows nothing. Now the reason I know it's a problem in the circuit, so the first thing I did is, okay, that's a problem. If we go to calibrate and then we turn this on, we have calibration. So we know the meter is working in that respect. At least the SWR meter and the well, let me look here, signal. Yeah, that's a signal meter. Okay. But when you When you go to transmit, when this control, the calibrate control, you have to go all the way down to the RF section. Then it measures RF output. And as you can see, there is nothing. So when you test for that, the first thing you want to do is check. See if we can zero in on this for you better, because I know it's really out there. Okay, I'm getting in as close as I can, hopefully. I can probably go in a little bit more. Let's see what I can do there. Yeah. Okay. Get here. Sorry, just don't have a very good situation for my camera here yet. There it is. See if I can point these out to you. Yeah, that's the way things go in the shop here. This is my part-time job now. It used to be my full-time. But anyway, I do this part-time now. And I'm still fixing 100 radios a month for part-time. These two diodes here. There's two right beside each other right here. I don't know if you can see them both because the one is in a dark spot. There we go. Now you can see both of them right in the middle. Right here. Both of these diodes is where you want to start checking, because that forms a halfway bridge circuit that converts the RF sine wave signal to a DC milliamp signal. And what you should see there at full bore, you can see up to 4 or 5 volts there. It's adjustable for that reason, because you can't send that much voltage to the meter. So when we check this, I'll try to show you. I'm going to go to transmit. And the only reason I left the receiver noise on, if you can hear it, is so that you'll know when I go to transmit. And I go here to this. Oh, I want you. Okay. I'll show you the meter movement on this, which is this meter here. And right now I'm on the 20 volt scale. So if we go here and transmit, you'll see that's 4 volts. If you watch me turn the power up and down, it actually will go up to as much as 9 volts. And the cap that I have in there is probably, there's an electrolytic that keeps that charge. See, it's probably coming back. That won't do that once it's fixed, because there'll be a load on it. There's no load on it right now. Then you go up to the here, you can see, okay, we got that voltage coming into VR8, which sets the power setting on the meter. But if we go to here, this is the wiper of VR8. Nothing there. 0.01. The 0.01 won't drive the meter. So the first thing we would have to suggest here is that that control is bad, because won't let anything through. So anyway, we're going to replace that. And we'll see what happens once we replace that meter. Now there's ways you could check this right away to make sure that's the case, but I can't see any other issue here except that that control is bad. It goes directly from the wiper directly to the meter. So there's no reason to think. The only other thing that could be would be, like I say, a dead short on the output end of the wiper between there and the meter. But I don't think that's the case. Besides that, the radio is 40 years old. Might as well replace that control. You can see I had to replace one here because it was bad. And As a general rule, these old Galaxy controls and stuff, they go bad. So I'm going to pause this thing here for a moment, and I'll be right back after I replace that control. Alright. Had to go take care of a phone call there from a customer, so I thought I'd show this. This is the bottom side, obviously, and the resistor, variable resistor, is located right here. So we take that pin, and then we have to get this pin. Get my trimmers here, get some this old stuff away from here. Alright, here. I don't know if anybody thinking about working on radios. I found this super wick to be especially good. Better, unfortunately, than stuff I paid more for. Anyway, that should release that. Yep, push on them, it is loose. So we'll go around the other side here. And we'll pull it out. See if we can get a image on this. See, it looks pretty bad anyway. I don't know if you can. I don't know if I can clean it off where you can see that. I don't normally worry about it, but since I'm making a video, try cleaning it, see if we can. Very hard to see that. Hard to see that. It's supposed to be 100K. You can see it if you look good. Usually on the thing like this, you can see the 100 there. It's hard to see the 100K. A lot of times they'll have a 102 on them. A 102 means it's 1 0, and the 2 means there's 2 more zeros. It'd be 1,000 ohms. The 100K, that would be a 100K, usually. Not always, but that's pretty much the standard. We'll pause this while I get a part. Alright, I found a part that will be okay. On this part you can see it says 104, which just means 1 0 and 4 more zeros, which would designate 100K. Now, a lot of times these things fit pretty easy, right, without doing anything. These, as you can see, are not exactly the same spacing on the legs, but that's not really a huge deal. You take a pliers, bend one out, bend this over. Don't worry about getting it flush to the board or anything. That's not critical. Look at it, compare it to your other one if it's not quite spaced enough. And take the other ones, bend them back a little. All it needs to do is get to a figure where, there we go, that should work. A spacing that will fit. I'm going to pull these back just a little bit more and then try to bend them so they go down more or less straight. Then we'll see if that will fit in there okay. Now these are different. They're not phenolic, they're plastic. The nature of the world we're in now. Parts are not what they used to be, but almost the entire industry, from computers to AM, FM radios to stereos to you name it, all use the style that I'm using here. Okay, I'm gonna slide this around carefully, and then we'll be able to put a little more light on this, and then you can see, I think you can, try to bring it in a little closer. See that there or not? Sorry, my glasses caught the camera. Solder that one in place. And solder that one in place. And then it's just a matter of testing it and see if we were correct. All right. Get up here, come back out. Oh, look, we now have power on the meter. All it was that control. Now it's showing an RF power of a little over 6 watts. It's actually about 5 full bore. But we'll get the proper alignment tool here. These measurements are pretty much relative. This isn't super accurate, but we'll go down halfway between the 4 and the 6. And then when we go down in power, it'll go down to 2. Just a little under 2. That's pretty good, because it's under 2 on my external watt meter. So that's good enough. And that takes care of the possible troubleshooting techniques you can use when you're working on one of these old, what they call black base radios. They're Galaxy Saturn here. It's an older version. See older 13, see older 14 board, 3614. And that cures another one of our issues. Well, if you view this and like it, that's all I care about. Appreciate your watching, and we'll try to make another video of the next thing we have to fix on this. That's it for today. 52, and we're out of here.